All right, guys, let's look at these. Okay, the first one, I would definitely simplify in the parentheses first, then deal with the exponent outside, and then finally deal with multiplying them together. So this first one, I'm going to leave the 2 and 3 alone to start with. Guys, how many x's do I have and where are they?
27.
Well, if I'm just simplifying inside the parentheses, 8 in the numerator. Do we see it? I'm just doing one step at a time. Okay. And then the y's, what would I have? In the denominator, right? And then I still have to the negative third outside. What does that negative exponent outside the parentheses mean? Yeah, everything is flipping. And then I'm also cubing everything, okay? So 2 cubed is 8. I know that's going to go in the denominator. 3 cubed is 27, and I have to move that to the numerator. So x to the 8th is going to become x to the 24th down here. Y to the 5th would be y to the 15th up there. One step at a time to that parenthesis. Okay, the other one. Again, I'm going to just simplify inside. So the 4, nothing's happening there. Looks like x to the 5th in the numerator. Y squared in the numerator. And then that z cubed will go to the denominator. And then I have to square all of that. Okay there? Okay, so 4 squared is 16. And then it would be x to the 10th, y to the 4th, z to the 6th. We okay to that point? Okay. I do not want to do 27 times 16. That sounds unpleasant, so I would reduce before I multiply. Always take the easier route, guys. So what can I reduce with the coefficients in these fractions?
8 and 16.
Yeah, so 8's gone, 16 becomes a 2. 2 times 27 is much more manageable than 16 times 27. So 2 times 27 is 54. Looks like I've got y to the 19th in the numerator. X to the 14th in the denominator, and z to the 6th also down there. Okay, how'd we do? Good there? All right, good, good. Anybody questions? It's easy to miss a sign somewhere along the way, so if there's any part of that you need me to walk back through, let me know. Okay. See a couple people writing, so I'm just going to wait a second, and I'll do the second one. All right, guys, what base am I going to use in the second problem? 2, yes, do. So 2 to what power? First, 2 to what power is 64? 6. Since it's 1 over 64, do you guys see how it has to be negative 6? And then that is still to the 2x minus 5. And then 2 to what power is 32? Yeah, 5. Hopefully you found that one on your way to 64. Okay, I know I have to multiply exponents and then set them equal, so I'm going to do that all in one step. So I've got negative 12x plus 30 equals 15x minus 5. Looks like 35 equals 27x. So 35 over 27 is your answer. Not a very pretty answer, but it doesn't reduce. That's it. Okay. Questions on the warm-up? Doing okay? All right. Okay, then. Switch here in a second. Notes, we have just a lot of really short examples, okay? Wait a second. Good. All right. So we're doing a bunch of different log properties. So first we're going to work on converting to log form. So I'm going to give you the exponential form and you're going to rewrite it in log form. Third period today kind of remembered some of this initially, but once we did an example or two, like everybody remembered, oh yeah, this is how this works. So you what? Okay. Some had an unpleasant experience with logs last year. We'll make it better this year. Okay, good. Okay, fair. Okay, so with this exponential equation, what is your base? 5. So converting it to log form, it's going to be a log with base 5. The exponent isn't going to be what you're taking the log of. The 125 is. So log base 5 of 125 equals 3. So the exponent is always what it is equal to. Logs and exponents are inverses of each other, so this is all just actually switching around the x and y and solving. We're not going to go through that whole process, but that's why these pieces end up where they do. Okay? And that's it. So example 1 done. They're all just kind of real short like this. There's not a ton of work to show. All right, 6 to the negative second equals 1 over 36. So you guys try, write it in log form. What do you mean, why? I get why when it's like this really long, tedious problem, but this is you just look at it and you write the answer. So, what are we going to write for this one? And it's not times 1 over 36, it's just of 1 over 36. Yeah, parentheses, however you want to say it. And then equals negative 2. I know we're not really used to reading it out loud. Like, you're like, how do I say it? Let's do a couple more of these. You're like, wait, but of means times? Yeah, that's weird. All right, try that one for me. You can leave it as a decimal, I don't care. Either one's fine. All right, so what is this one? Yes. And guys, I didn't write the 10. Why didn't I write the 10?
Because
Log just means 10. Yes, that's called your common log. If a base is not written on a log, it means base 10. Common log. The commoners. Yeah, don't write the 10. Yeah. Is that what you're going to ask? Yeah. That tells me you don't know what it means when no base is written. You don't write the 10. Maddie's like, I don't buy it. Don't write the 10. And just like with the next one, you're not going to write something else. Let's see. I have e to the x equals 4. Okay, let me talk you through what you should think, and then what you should actually write. So what is the base here? E. So you're thinking, okay, this is log base E of 4 equals X. Don't write this. Okay. That's absolutely what you're thinking. It is not what the answer is. Does anybody remember which log is a log with base E? Natural log, which we write ln, not nl. So this is natural log of 4 equals X. And yes, I would take off if you wrote log base E. Natural log, that's an L and an N. Yeah, Tyler. How come what? Sorry. So natural log means log base E. Just like on number 3, a common log means log with a base of 10. So those are the two that you should know what the bases are, and you don't write the base. So anytime you have something going on with an E, you're looking at natural log. Okay, let's go the other way. So I'm going to give you the log form, and you're going to write it in exponential form. Log base 2 of 8 equals 3. I think their lunch just ended. They're waiting. So what is the base of this one? Okay, 2 to the what equals what? Okay. Now, with all the numbers, that's pretty easy because you just know 2 cubed is 8. You won't always have those numbers, so sometimes you'll have variables in there. 2 ways you can do this. You can either just essentially memorize like base, this is the exponent, equals the other number. Or you can do what's called exponentiating, where you put the base on both sides. I'm guessing most of you, do you just look at it and you know, like, this is where the pieces go? Yes. Okay, that's completely fine. As long as you can do that accurately, I am good with that. So let's try another one. Let's do natural log of A equals 3. Write it down. You think you got it. So what is the base here? E. It's not written, but we know it's E. So this is E to the 3rd equals A. Okay with that? Base, exponent, what it equals, okay? Just go through that process. We'll do a few more. Let's do log of 100 equals 2. Let me write 2 of them up here for you. Log base A of B equals C. Try both of those. Check in with your neighbor. Did you get them? right, guys, let's look. Did you get them right? So number 7, what's the base? 10. So this is 10 squared equals 100. Hopefully we got that one. What about 8? What are we going to say? It's real loud and then real quiet. Yes, A to the C equals B. All right. Are we okay with rewriting? Sure. All right. Let's do some evaluating. Log base 2 of 16. So there's no equals. You just have to evaluate. In other words, what is the value of log base 2 of 16? So what you're thinking through is 2 to what power is 16? To the 4th. Yeah, so the answer of log base 2 of 16 is just 4. So again, you don't really have to write any work for this. Like, you just think through, okay, what exponent am I looking for? And that's your answer. Let me give you a few here. Let's do log base 5 of 1 over 25. Let's write 3 of them here for you to try, okay? Log base 16 of 4. And log base 7 of 1. Do a few here. Check with your neighbor. Do you have the same answers? They're a little trickier than number 9.
What happened to your
I put it away because one of my class periods is having issues with people wandering. So I was like, fine, you just get one pass. So. Yep. Bad for everyone. 7. They know. All right, guys, number 10, what'd you get? For 10? -2, yes. You know 5 squared is 25. We need it to be a fraction, so it is -2. All right, what about 11? 1/2, good, we remembered. I need to take the square root of 16 to get 4, which means I need an exponent of 1/2. And what about number 12? Yay, you guys are crushing it. 7 to the 0 is 1. Nice. Let's do 2 more in this little group. I'll write both of them. Log base 27 of 9. And natural log of E. How what?
Do I write actually? Just N.
ln. But I don't know why I use just this kind of L for log and then this kind of L for natural log, but I do. Natural log of E.
Basically, yeah.
It's not E of E.
It's for E of what equals.
Correct.
Oh, for one.
Is that
ln of E. Natural log of E. You gonna be okay, James? Do you agree with your neighbors?
Yeah.
13's a little bit tricky.
Is it 1/3?
It is not. Guys, what'd you get for 13? 2/3. I like that. Let's go through what we're thinking about. 27 to what power is 9? Right? That's what we have to think about. It's kind of like your warm-up. You need the bases to match. So I know 3 cubed. And yes, I'm using a question mark instead of a variable. So 3 times what would equal 2? The what is 2/3, okay? Do you see it if you solve for a question mark? Yeah, okay. All right, what about number 14? 1. That should be kind of automatic, like when we get into simplifying some things later. When you see natural log of E, you just automatically know, oh, that's 1, okay?
Oh.
E to what power is E? 1. All right, let's do, which one? 2/3 and 1? All right, we're gonna start using some properties to evaluate. I don't know what number I'm on. 15. Log base 4 of 4 to the 5th. We're going to evaluate. There's 2 ways you can do this one. The first is just like we've been doing, where you go, okay, 4 to what power is 4 to the 5th? 5, okay. The other way is with a property. Guys, do you remember from last year when you have exponents in logs, where can I put that exponent? In front, it becomes the coefficient. So this is the same as 5 log base 4 of 4. Guys, what is log base 4 of 4? 1, yeah. So also an answer of 5. Use whichever one makes the most sense. You will have to use the exponent rule for some of them, but this one you can do either way and it's fine. All right, let's try again. All right, this one's a little weird looking, but it's actually really easy. 9 to the log base 9 of 2. As I said, it looks weird. If you had to take a wild guess, what would you say the answer is?
37. 9.
When you've got the bases, they're essentially canceling each other out. So it is, anytime those bases match, it's going to just be that other number. Let me show you why on one you can actually evaluate. let's say I had 2, just gonna throw this guy in here, 2 to the log base 2 of 8. Based on the example we just did, what would you tell me the answer is going to be? 8. That is correct. Let's see why. If we evaluate the log part of that, what is log base 2 of 8? 3. So this is really 2 cubed. And what is 2 cubed? 8. Okay, so it's not just like, oh, well, there's an 8 there, that's the answer. Like, it really does work. But like the log base 9 of 2, that's not one you can evaluate by hand. So, but that's where it comes from. So anytime you see matching bases like that, it's going to be the other number. All right. Okay, let me write a couple for you guys to try. So, log base 9, 9 to the 11th.
So, excuse me.
Yeah.
So for 2 to log 2 to the 8. How do you get 2 to the 3rd?
What is log base 2 of 8? What is that log if you evaluated it? 2 to what power is 8?
3.
Yeah? Okay. Let's do 6 to the log base 6 of 7. Try those two. All right, guys, what'd you get for number 17? Yeah, because log base 9 of 9 to the 11th is just 11. Log base 4 of 64 is, what's 3? So 11 minus 3 is 8, not 7. And what do we get for 18? Okay. All right, questions on any of those?
Is it ever going to be so that the base of the log and the x function and the number and the normal line is going to be different? Or is it only
Like 5 to the log base 6 of 7?
let's just say
You can't evaluate that then. They only work if the bases match.
We'll always see it.
The bases have to match. Okay. The bases don't match, you cannot evaluate. There's like a certain dismissal time, but yeah. All right, next section, we are going to condense. So we're going to keep looking at our properties of logs and use them to condense things. The directions you might also see could say write as a single log. Let's do log base 2 of 5 plus log base 2 of 7. And let me walk you through this one. Think back to basic exponent rules. If I had x cubed times x to the 4th. What would that be? Okay. So you add exponents when things are multiplied together, right? Here I'm kind of going the other way. I have these logs added together, which means I can condense them with multiplication. So I can turn this into a single log base 2 of 5 times 7, or log base 2 of 35. So when you see addition between two logs, that means multiplication. Let's try another one. Let's do log base 3 of 45 minus log base 3 of 10. Okay, addition, connected it to your exponent rules. We know that meant multiplication. What do you think subtraction? Yeah. So this is log base 3 of 45 over 10. And we could simplify that to log base 3 of 9 over 2. Oh, sure, it's fine. Questions on that one? All right, let's throw another property in there. 5 log base 2 of x minus 2 log base 2 of y. It's crazy. That's not crazy. Oh, okay. I'm dropping that a lot today. All right, guys, try it. Can you write it as a single log? Yep, you can. Give you a second here to think about it. Got it? All right, we talked earlier about how the exponents could become the coefficients. So we're kind of going in reverse here. Like that 5, what is that really telling me? Yeah. So I've got x to the 5th, and then I see subtraction, so I'm going to divide over, what will it be? Y squared. And that is your answer. Now guys, the condensing, you can only do that when your logs have the same base, which all of these have, but don't try to combine two different bases. It won't work. Okay. We are going to, sorry guys, I don't remember what number I'm on. 22, okay. We are going to expand now. So the opposite of condense. Let's do log base 3 of 9x. Okay, when I say expand, I want you to break this into as many parts as you can without breaking it into. I see 9 times x. So what does that mean I'm going to put in between my logs? Plus. So I'm going to have log base 3 of 9 plus log base 3 of x. Can I simplify either of those? Yes. What is log base 3 of 9? 2. So your answer is 2 plus log base 3 of x. Okay. That's it. You expanded.
Look at a situation where we have to go backwards and it gave us the 2 also we don't want to send that to backwards.
Oh, like where you have to turn the 2 into a log? That could happen. You just look at whatever the base is. So like, let's say the other one was base 4. You'd know, okay, that's got to be log base 4 of 16. Like, the 2 is just telling you what exponent to raise it to. So it's not as bad as it looks.
It is, but
It is not. All right, let's do log base 2 of x over 7. Try that one. All right, what do we think, guys?
I'll just do x.
Wait, no, that's it.
And then it goes x and then it's on top of x.
Because the numerator and then the denominator. You could write it the other way, but you'd have to say negative log base 2 of 7 plus log base 2 of x. It's much more complicated than this. Yeah, here.
What if you get negative log 2x minus log 2z? How do you write that?
Then both of those would be in the, like if you went to condense it, it'd be 1 over, so you'd have your log base 2. It'd be that. And we'll do a couple with a lot of negative parts here in a minute, so ignore that. Separate question. Let's do one more in this section. How about natural log of 4x cubed? Expand that for me. Okay, guys. Another second here. Check in with each other. Do you agree? All right, so I'm going to have natural log of 4 plus 3 natural log of x. How'd we do? Got it? All right, let's keep expanding. Let's make it a little more complicated. Just for fun. All right, let's do natural log. Okay, try that one. Natural log of a times b times x to the fourth over y squared z.
You love us so much.
I do.
You're a Z.
This is the z. I always draw a line through my z's. That really isn't that bad. There's still like no real work involved. You just write the answer.
It's only two, right? Two logs that you separated it to? It's fine.
5. That is a z. It's a heavy side, Tyler. You got it? Okay. All right, let's look, guys. You should have 5 natural logs. I'm going to do this in 2 steps just to emphasize the negatives for you to make sure you see it. Natural log of A plus natural log of B plus 4 natural log of X. We're all good with that, right?
Yeah.
Okay. Then I'm going to put minus, and then in parentheses, because all of this is in the denominator, 2 natural log of y plus natural log of z. The y squared and the z are multiplied together, but that is all in the denominator. So if you wrote it without parentheses, natural log of a plus natural log of b plus 4 natural log of x minus 2 natural log of y minus natural log of z. That is your answer. It is a big answer. That is expanded very largely. I would take either one, but I want to show you the negative part to help you. Guys, we're going to condense like from this back to this too. So recognize anything with a positive leading coefficient, that came from the numerator, right? Anything that has a negative leading coefficient came from the denominator. It should make sense because that coefficient is really your exponent. So negative exponents, put it in the denominator, okay? All right, one more expanding like this, and then we'll condense a couple. Let's do x plus 1 cubed, y squared, ab to the 4th. So this should be quicker since we just did one like it. Guys, can you break apart the x plus 1?
No.
No. Good. It's not multiplied or divided, so no. Yes. Are we ready? Sure. All right. Did you get 3 natural log of x plus 1 plus 2 natural log of y minus natural log of a minus 4 natural log of b? Yeah? Okay. Yay. Good, guys. That's like as complicated as it would get for expanding, okay? All right, condense. Well, that was expanding. We're going to condense some complicated ones like this. Yeah, but not complicated ones like this, so we'll do just a couple. Or one, maybe. Let's do 3 natural log of x minus 2 natural log of y plus natural log of 8 minus natural log of z. If you guys are good with this one, we'll just do one. So in the end, you're going to have a single natural log, okay? Check in. Did you get there? James, that looks like you guys don't agree. Oh, okay. Anna, you have the same thing? All right, let's look, guys. Remember, positive leading coefficient, it came from your numerator, negative came from your denominator. So we definitely have an x cubed in the numerator. What else is in the numerator? 8. You absolutely could write 8x cubed. Yes, yes, yes. Denominator, do you guys see y squared and z? 8x cubed instead of x cubed times 8. Are we good on that, Kai? Yeah? Okay.
That was a Z. I thought that was
You need one more? Oh, you only need to do one. Good. That's what I was hoping for. All right. Last 2 examples. 2. Because I got to show you one. So, given that r is equal to the natural log of 2, s is equal to the natural log of 3, and t is equal to the natural log of 5. We're going to rewrite these natural logs with just r's, s's, and t's at the end. So let's do one together. So natural log square root of 15. Let me explain it, and then you'll try the next one. So we have 2's, 3's, and 5's to work with. We're going to do some expanding here with our natural log, and then at the very end, substitute in our letters. So, what exponent tells me square root? a half. And where could I put that exponent? In front. So this is 1/2 natural log. And then how can I make a 15 out of the 3 numbers I have as options?
S and T.
Okay, we don't do the letters yet. So 3 times 5. Because you can't substitute until it's just natural log of 3 and just natural log of 5. Okay. From here, then, I can expand. I know, it'll come back. So this will be 1/2 times natural log of 3 plus natural log of 5. So I can say 1/2 times S plus T, or you could say 1/2 S plus 1/2 T. Either of those are fine. Or S plus T over 2, all of that works. But do you see what I mean? Like the letters do not get substituted in until after you've done the expanding and all of that. Okay. No, you need to try one. Trust me. Last one, guys. Actual last one. All right, let's try a natural log of 25 over 6. The angry face won't make it go away. No, we're stopping at 29. Oh yeah, you kind of, like, do you need the problem before it or just those? Okay. Same given information. So no, all of the expanding before you put any letters. You shouldn't have any natural logs left in here.
Actually, no, I think that's crazy. Yeah, I do.
Something.
I don't know. I know. I just don't understand why. Because I don't Yeah.
All slide. Okay.
So this it makes no sense.
That's me. So that actually
That's what everybody
not his fault. So how do you make 25 out of it?
He's also like
Tell your mom, don't text me during the day. All right, guys, let's go through it. You can think of 25 as 5 squared or 5 times 5. Either way is fine. And 6 is going to be 2 times 3. When you expand this, and I know it's not writing everything I'm writing, it'll catch up. You what? Not really, because a lot of it you can do in your head. Guys, once you're here, remember expanding with division, we have subtraction. We don't write it as divided anymore, okay? It's subtraction. And then you can substitute in. I've got t plus t, so I'm going to write 2t minus r minus s. And that is it. Does that make sense?
Yeah.
Okay. All right, good. All right, guys, any questions? Okay, you've got about 10 minutes to work on your Delta math. So go ahead and get started. Again, I don't see you for a week. So
When's the test?
there's no like extra homework happening.
When's the test?
The 27th. 20 days from now, yes. Part of it is because October's weird and we just miss a lot of days.
The order is
Yeah, 28th? No, 28th is the end of the